I'm going to ask you a very simple question. What is computer science? Now, the first thing you might have thought of is that computer science is just, well, computers. And you probably aren't the first one to think that. Many people, when they hear about computer science, they just think, hey, isn't that just about computers and how to fix them? Well, that's not exactly the case. Although computer science does include about computers and how to fix them, it's way more than that. Computer science is such a broad term and includes so many different fields and principles that many people aren't really aware of what those fields and principles are. I'm Amali, and I'm going to tell you the variety and diversity in computer science and how much the world kind of depends on it. Computer science includes fields like networking, programming, physics, and so many others, and even includes principles from economics and sociology when you really wouldn't think computer science would link to all of these kind of topics. Now, the question you may be having now is, how does computer science really link to all of these different fields and principles? Well, I'm going to tell you. Let's start off with networking. Let's say we have a company, and in this company, you would have desks and computers and probably a coffee machine, but that's besides the point. What we'll be looking at here is the computers. And now, even though you may not see it, these computers are tied up into a computer network. What is a computer network exactly? Well, it's basically a group of computers that uses a set of common communication protocols over digital interconnections on a network. Now, this may sound complicated, but it really isn't. Because this is a company, it will normally be a big computer network. But just as an example, let's just look at a computer network for two computers. So here we have Jim and Jimmy, and they're on their computers doing their business work. But their computer network isn't just two computers that they're working on. If we see here, we can see that these computers are each connected to a switch, which are switch A and B. And switch A and B are both connected through two wires. Now, as an example, let's say Jimmy wanted to send off a message to Jim about a meeting this afternoon. So Jimmy sends a message. This message will be sent out to switch B through the wire that's connected between switch B and Jimmy's computer. Now, when the switch receives a message, the switch will send the message through ports where the wires are connected to. And since we have two wires connected to switch A and B, this means when they receive a message from Jimmy, the message is going through both the top and the bottom wire connected with switch A. Now, a switch never sends a message back from the same port that delivered the message. Switch A received a message from Jimmy. It will message through the ports where it did not come from. So switch A will send the message to Jim's computer through the wire that switch A and the computer is connected to. But it doesn't stop there. Because there is two wires connecting to switch A and B, the switch will then read the message sent out from the top wire and be like, hey, I was not sent from the bottom wire. I was only sent from the top wire. So when switch A will read this message, it will send the message back through the bottom wire again, back to switch B. And then we will also have the bottom wires package saying, hey, I was only sent from the bottom wire and not the top wire. So the switch will read this message also and send this message back to the top wire, back to switch B. Now switch B will receive the messages again and will think the same way switch A did and send the messages through the top and the bottom wire back to switch A. And this will just create an endless loop between the two switches sending the message. Now, how can you solve this problem? Well, with networking protocols, there's a protocol called STP, a spanning tree protocol, that basically stops these endless loops from happening. STP is a protocol that ensures you that you don't have to create loops and have a redundant path in your computer network, because loops are quite deadly to your computer network because it'll become endless and endless, and this could just overfry your switch. So once you put a STP protocol on these two switches that Jimmy and Jim are connected to, their switches won't fry, and they could be sending endless messages to each other without the loops. Now, with this example, you can see how computer networking and computer science kind of meshes together and correlate with each other. How? Well, without networking, we couldn't really have done and fixed the problem that happened with the company's computer network. So now that we know how computer network is kind of vital and works along with computer science, how does programming work with computer science? Well, let's look at it with another example. What do you always have in your hand at most times of the day? Your phone, right? Well, when you open your phone, what's the first thing you see? Your apps. And why am I bringing that up? Well, because apps background is based on coding and programming actually. And in specific terms, this is what we call app development. And it's basically the building of apps. Many apps such as the built-in apps like calculator, clock, calendar, contacts, and so much more were programmed and created by people in the computer science field at places like Samsung or Apple, as you normally hear. Programming like app development links with computer science because computer science is innovative and creates applications that you never would think you would need or want. And programmers do this through app development, creating spectacular apps on phones or tablets or really any interface that can allow it, with the imagination that they would like to put in the app. That is truly how programming and computer science link together and correlate so well with each other. And maybe now you'll be asking, how about physics correlating to computer science? Can physics, a science field, ever link to computer science? If you really think about it, you can see that physics isn't just a science field, just like how computer science isn't just about computers. Physics contains topics such as electrostatic and electric forces that are quite important to learn in computer science. Electrical forces are results from a friction or interaction between two charges, and in some situations, it can involve 2, 3, or more charges. As an example of how physics can be used in computer science, let's just use an ordinary, boring printer. And you may be questioning, how does a printer, out of all things, can relate to physics, computer science? Well, the inkjet printer is a common used printer, but I bet you didn't know that it applies electrostatic forces as it prints. In a printer, we have various parts in them, but the most important part in this explanation is the mirror, the drum, the toner, the laser, and the fuser. So when the laser gets a signal from the computer wanting to print, the laser then hits the drum at different points, and those same very points becomes a negative charge. The solo hopper then has a powder in it which is like the ink for the paper, and this powder is positively charged. So when the drum goes near the powder as it is turning, the positively charged powder then becomes attracted to the negatively charged drum. And like they say, opposites attract. So the positive will attract the negative, and the negative will attract the positive. So when the powder sticks to the drum, The paper that is negatively charged that is going through the printer then passes by the drum. Now the powder that was then stuck onto the drum then transfers onto the negatively charged paper, and the paper goes through the feeder, which basically fuses the paper and the powder with heat, so the paper is now printed with the desired word on it. Physics basically links to computer science by helping it to build more on the logic computer science has. The fields of computer science are really interesting, to say the least. It can require a lot of logic and creative out of the box thinking. But what really is amazing is how computer science can link to even sociology and economics. But how can that happen? Well, let's use global certification as one of the principles that can be used on computer science. Belize is a third world country, and so is Guatemala. A third world country is basically a country that's still in development. Even though both Guatemala and Belize are third world countries and still developing, Guatemala has so many opportunities that are provided to study in the IT field. While in Belize, there isn't as much places where you can fully study computer science. In Belize, you can't even get an IT professional certification, such as a CCNA, which is basically a Cisco certification which offers you the knowledge of the 5 layers in networking. In order to get this certification in Belize, you would have to travel to either Mexico or Guatemala to take the exam. This is how global certification is played into computer science. Now, supply and demand can also be added into computer science. How? Well, in Belize, we have high demands for people who study computer science, especially women. But in the field of IT, we have such a low supply of education towards computer science fields. Although men are seen as more of a IT professional and females aren't, they are both still in a high demand. Though in Guatemala they show us more of an opportunity, and especially for females. And maybe in the future we can change that, because with all these examples I have given you in this video, you can see how it's really important to know some of the stuff that is taught in computer science, like networking and programming and physics. And there are so many other topics that you can learn in computer science if you don't want to study any of the ones that I have mentioned. But now I've shed a little light on you, and you can see how much these fields and principles can links to computer science, and even now how computer science can connect to the world. Thank you.